Okay, hi everyone. This is Infinity YouTube channel. Please remember to like, subscribe, and share. So today we are going to work on an example on our small sample. We are going to work on an example. So the question says a sample of 10 measurements of diameter of a circle giving a mean, and they gave us the mean, which is by x equals 4.38 cm, and a standard deviation s equals 0.06 cm. They say we should find a 95% confidence limit for the actual mean diameter. So the first thing you have to consider here is the total number of variables that we are going to work with. From here is 10. Okay, so since it's 10, that means we are 1 inch forward on using our small scale. So the next one is check if you are given sigma. So like in this question, we are given the standard deviation s. Okay, so we can go ahead to solve our small using our small sample. Now solution. Remember that the formula for our small sample is given by x plus or minus t alpha over 2 comma n minus 1 standard error of x. And from this question, our by x was already given as 4.38. So we only need to evaluate our t alpha over 2 minus comma n minus 1 and our standard deviation. So that's the two things we are going to solve for. So we know, as usual, we are going to subtract 1 minus alpha over 2. Okay, we're going to subtract 1 minus alpha over 2. So in your statistics table, you are going to see one-tailed or two-tailed. So the only thing you have to trace is only on your two-tailed. Just trace your two-tailed, because in our confidence interval we deal with two-tailed test. Okay, so check, you see your two-tailed there, and 1 minus alpha over 2 here. Since we are given a 95% interval, it means that our alpha is equal to 5%, and 5% is 0.05. So, and from, as usual, from our formula, we are to subtract 1 minus that alpha over 2. So which means t of 1 minus 0.05 divided by 2. And if you should do that, you're going to have t of so you're going to have 0.975. Okay, but remember, it's actually comma n minus 1, where n minus 1 is our degree of freedom. Where n minus 1 is our degree of freedom. So, and here n is 10. Okay, n is 10. So just subtract 10 minus 1, which is 9. So in our confidence interval, in our statistics table, so we are going to use this standard, this degree of freedom, and we are going to look for this value. So if you should check your table, the answer of this in our small scale table is equal to 2.262. Okay, 2.262. That's the value you are going to have. Next is to determine our standard error of x. So to determine our standard error of x is equals to s divided by square root of n. So, and our s was already given in the equation as 0.06. So just here 0.06 divided by n, which is 10. Our n is 10. That is the square root of 10. And if you should do that, we are going to have 0 point, going to have 0.01897, 0.01897 approximately. So we've gotten all the values that we need. So the remaining thing is just to impute it into our formula to get our confidence limit. So our by x rather, is given by 4.38. So our x is 4.38, plus or minus our t alpha over 2 comma n minus 1, which is gotten from our table, from our statistics table, was 2.262. So just come here, 2.262, and of course it's being multiplied by our standard error of x. It's being multiplied by our standard error of x, and our standard error of x is 0.018 times 0.01897. So this is how to evaluate this function. Now the next thing is to bring this down, plus or minus, so multiply this. So if you should multiply, you have 2.262 multiplied by 0.01897. We have 0.04291014. So that's what we have. So to get our upper limit as usual and our lower limit is to, for your upper, add the values, and for your lower, subtract the values. That is the meaning of this plus or minus. So for our upper, that is 4.38 plus this value, which gives us 4.38 plus 0.04291014. So the answer is 4.42291. 4.42291. That's the value you're going to have. And when you get subtract the value of your lower limit, you're going to have 4.33709. So that's the value of your lower limit. So this is how to evaluate our small sample. But in a situation that n is equal to 10 or is lower than 30, and your sigma was known, know that you are going to use your large sample, not your small sample. So for your small sample to hold, your sigma must not be known. Sorry, your sigma must not be known, which is your standard deviation must not be known, and it must be less than 30. That is only two situations that will make you to use your small sample. But if sigma is known and your n is less than 30, you can always use your large samples. Thank you. I hope this video was useful. Please remember to like, subscribe, and share.